Now let's look at a slightly different set of operators called as logical operators. Just like in every major programming language like C, C++, etc., you have a bunch of logical operators. There are some logical operators that are unique to SQL. We all know the and, or, not, etc. There are some special ones like all and any, between, exists, in, like, and some, right? We'll go through some of them in this video. The others we'll learn when the right examples or when we learn some additional techniques or additional methods, right? So now let's start here. Now you might wonder, what is the use of these logical operators? So let me give you a real world example so that you can better appreciate what is happening. Right here again, I'm in a t-shirt search page for a retail company called Amazon. Here, if I want to filter all those t-shirts whose material is cotton, look at this, the material here is cotton, right? I've ticked the cotton part. And if I want the brand to be Flying Machine, right? This is a very simple and useful thing, right? If you think about it logically, I want the material to be cotton and I want the brand to be Flying Machine. It's a logical and, right? So when you have multiple filters like this, when you pick two filters, you will have to use logical operators. So let's go back to our example of movie database and see some examples, right? So imagine if I want all the movies whose rank score is greater than 9, which means they're highly rated, and which are released after the year 2000. So here I have two conditions. This is condition 1, which says that rank score should be greater than 9. And I have the second condition, which is year greater than 2000. And both of them I'm combining using the AND operator, right? So if you see this, so let's execute this and see, right? So if you take this and execute it in the terminal that we have, right? So these are all the movies. These are all the movies that are released after the year 2000 with a rank score of greater than 9, right? So because this is important, because if I want to only watch movies post 2000, and if I'm looking for good movies or highly rated movies, I will have to use this logical operator AND between these two conditions. This is condition 1 and this is condition 2. Very simple thing. Very, very simple example. Now let's look at just the way we have seen logical AND. Imagine if I want a slightly different answer. I want to look for all the movies where the year is not less than equal to 2000. So look at this. This is the condition here, right? Where not year less than equal to 2000. What does this mean? This means where the year, okay, so this is a condition, right? Year less than equal to 2000, and we are placing a not in front of it, which means this is equivalent to year greater than 2000. Whether you write year greater than 2000 or you write not year less than 2000. This is a simple logical operation, right? So this will either evaluate to true or false, and the not will invert it. This is like a logical not that you see in all programming languages, right? Similarly, if you want to use logical or, right? Suppose if you want to watch movies whose rank score is greater than 9, which means they're very highly rated movies, or the movie is recent, right? If the year is greater than 2000, that means it's a recent movie. So you want to either watch a recent movie, or this is the logical or here, or you want a highly rated movie from any year, right? So this is where you see these logical operators of and, or, and not. Very, very simple. These are just like your logical or, logical and logical not that you see in most programming languages like C, Python, Java, etc. There are these two special logical operators called all and any. We will discuss these two things when we learn of a concept called subqueries. We will learn that is one of the future videos in this chapter, right? So without learning about subqueries, learning about any and all will feel like theory. I don't want to teach just blunt theory. So it's better we learn these two logical operators when we learn about subqueries, so that you understand the context in which these logical operators are useful. So I'll hold these two for now, okay? We'll look at both these a little later. Now let's look at the rest of them, right? So now let's look at this operator called between. Okay, let's see an example here. Here I have select name, year, rank, score from table. These are the columns I have, and this is the table I have where my year, look at this. This is the condition where the year between 1999 and 2000. This is how you use the logical operator between. So what this does, this is same as, if you want to write it without using the between, you can write it as year greater than equal to 1999 and, right, year less than equal to 2000. Right? This is called the inclusive. This is called inclusive range, because whatever values I say, these values are included. So whether even if it is equal to 1999, you will get it. Or if it's equal to 2000, you will get it. So this will list all the movies which are released, right? Where the year is greater than equal to 1999 and the year is less than equal to 2000. This is what it is equivalent to. That's why I've written it. We call it inclusive range because both these values are also included in the results. Right? So this is how you use between. There is a subtle detail about between that I wanted to explain you. Right? So for between, right, you have these two values, right? You have these two values. Look at this. You have these two values. This is called the low value. This is called the low value. And this is called the high value. Now, instead of using these two, if you invert them, instead of writing this query, if I change it to select so-and-so columns from movies where year between 2000 and 1999. Here, my low value is greater than my high value. Right? So this will not work. What this is equivalent to is, this is equivalent to year greater than equal to 2000 and year less than equal to 1999. That's impossible, right? So whenever your low value is less than your high value, right? Whenever your low value is less than high value, everything will work well. So your low value should always be less than equal to high value. Otherwise, else, for this query, if you execute this query, this SQL query, you will get an empty set. Because an year cannot be greater than 2000 and at the same time being less than 1999. That's impossible. It's against the rules of simple numbers, right? So you should always, whenever you're using the logical operator between, you should have the first value or the low value to be less than equal to the high value. Otherwise, you'll get an empty set. This is an important detail that we should not forget. Okay. So what all have we seen till now? Okay. So just to keep the context, we have understood and, or, not. We said we'll discuss them later. We've also discussed between. Now we have exists, in, like, and some. So let's go through each of them. Okay. These are all logical operators, very simple operators. Now let's see how in is useful. Okay. Suppose if I want to print the director ID and the genre of the movie from this table called directors underscore genres, where I want my genre to be either comedy or horror, let's say. Okay. So if I want my genre, let me just edit this. Suppose if I want my genre to be either, comedy or horror, what do I do? One way to write it is select director ID comma genre from directors underscore genres where genre equals to comedy or genre equals to horror. This is one way of writing it. But when you write it like this, you're repeating this. Look at this. When you write it like this, you're repeating the genre equals to here. The same thing you're writing it here. If you want it between three genres, right? Genre equals to comedy or genre equals to horror, or let's say genre equals to, if you want, equals to, let's say, drama. Right? So what is happening in this case is you're repeating this genre equals to this text, you're repeating it every time. Is there a a shorter form of doing this. That's where you have this keyword called in. So let's see how it works. It works like this. You're saying select director ID comma genre from the table name. This is my table name, where if my genre belongs to, or if my genre is in this set. See, look at this. This set I'm representing using two braces or parentheses. Within the parentheses, I'm mentioning all the genres that I want. So if the genre is equal to comedy, or if the genre is equal to horror, right? This will return the director ID and genre, corresponding director IDs and genres. So this is genre equals to comedy or genre equals to horror is same as saying, if my genre in is the keyword here. If it is in this set, if my genre is in this set, then make this condition equals to true and output that corresponding row. Right? That's how you use the comparison operator or the logical operator in. Right? Now let's look at the other ones. There's something called as like. Very interesting actually. I really like the comparison operator. So let me explain that. Again, I'll share this whole text file with you. You can open it and you can run all of these commands in your terminal, right? You can comfortably run. So for example, if you see this, okay, you can simply copy paste this, copy it, Control C, go to your MySQL terminal, Control V. So wherever this is the director ID, horror/comedy. Wherever you have horror or comedy, you'll get the output. It's that simple, right? Okay. So you can run all of these commands, will work. Now let's look at this this logical operator called like. Let's see what like does. Okay. So like does something called as text matching. So let me explain this for you. That's easier. Suppose if I want the name, year, and rank score of movies where the name starts with TIS. After this, there could be anything. Okay, if I want the names of all the movies, the information of name, year, and rank score from my movies table where the movie name has TIS followed by anything else. Okay, so let's see this. Okay, let's see this. Copy this and paste it and let's see what happens. Okay, if you see the result that you get, the result set that you get, everything starts with TIS and TIS can be followed by anything. Here TIS is followed by OY. Here TIS is followed by something else. Here TIS, but the only thing here common is all of these names start with capital TIS. So the operator like, right? What it does is you can input something like this. Let me explain what this is. This means that the first character has to be T, the second character has to be I, the third character has to be S. The percentage here is called as a wildcard character. This percentage symbol is called as a wildcard character. And this percentage implies 0 or more characters. So what it means is, as long as the name of the movie starts with TIS, and if TIS is followed by anything, it could be empty. If TIS is followed by anything, even empty stuff. So this condition will match, where if the name is just TIS, it will match if TISU, it will match TISAM, it will match all of them. So percentage basically means this is followed by, TIS is followed by 0 or more characters. So this logical condition will match TIS because there are 0 characters after TIS. It will match TISU because there is 1 character after TIS. It will also match TISAM because there are 2 characters after TIS. The only requirement is the first 3 characters are TIS. This percentage is called a wildcard character. This is used in lots of languages, right? This is used in, like if you know shell scripts, this is used in similar type of wildcards are used in a command called grep in Linux. Okay, most programming languages like Python, Java, etc. have ways to match strings like this. Using these are also called as regular expressions. Okay, So your grep or regular expressions. Again, we will learn about regular expressions in when we learn about automata theory, right? So grep we'll learn in operating systems. Okay, this is where, so these are concepts that are across multiple subjects in computer science, right? If you're a computer science student, you would have come across something called grep in operating systems, or if you have learned automata theory, regular expressions. If you don't know these, it's okay. Don't worry about them. It's perfectly okay. For those of you who know, you'll be able to appreciate these relationships. If you don't know, that's perfectly okay. Or if you're not a computer science student, that's also perfectly okay. Okay, so this is done. So let's go and understand the next one. Okay, suppose if I want all the actor names, so we'll see some variations of like, right? If I want the first name and last name from my actors table, where the first name is like, say, look at this, my first name like this. Look at this condition. It says my first name like percentage ES. What do we know percentage to be? Percentage basically means 0 or more characters. 0 or more characters. That's what percentage means. So what this is saying here is, as long as my first name ends in ES, as long as my first name, that's what the last two characters are fixed here. Here the first three characters are fixed. Here the last two characters are fixed. So this will match if my first name is ES, or if my first name is ZES, or if my first name is FACES. It will match all of them, because here I have 0 characters before ES. I have nothing. Here I have 1 character before ES. Here I have 3 characters before ES. Since percentage represents 0 or more characters, right, it will match all of them. So let's actually execute this and see, right? So let's execute this and see. Okay, go to a terminal, clear the screen. That's it. If you look at this, look at all these folks. All of their first names are ending in ES. Look at everyone. All of their first names are ending in ES. Okay, ES, ES, ES. All of them are ending in ES. That's what we asked, isn't it? Isn't that what we asked? That's exactly what we asked, right? So these characters, so like is a very useful thing to match strings. It's very useful to match strings, and these special characters like percentage are very, very powerful. So since we have seen percentage as a wildcard character that matches 0 or more characters, right? Is there some wildcard character that will exactly match one character, exactly one character? So there is a wildcard character called underscore, right? This underscore symbol. This implies exactly one character. This is also a wildcard character, just like your percentage, which is used in like a lot. Let's see an example where this is useful. Imagine if I want to find the first name and last name from actors, where the first name should starts with A, followed by G, followed by N, followed by any character, but a single character, just exactly one character, followed by S. If I want, see this, what is my condition? My condition is that my first name should be like this. So let's look at some words that will match this type of string, right? Of course, Agnes matches because there is exactly one character. Similarly, Agnes will match because there is exactly one character. But AGNS will not match because there are 0 characters between N and S. Even though A and A will match, G and G matches, N and N matches, S and S matches, there are 0 characters here, so it will not match. Similarly, Agneus will not match because there are 2 characters, right? So underscore here is also a wildcard character, just like percentage. While percentage is a wildcard character which implies 0 or more characters, underscore basically implies exactly one character, right? Now comes an interesting twist. What if? Okay, let me take a slightly interesting example. Imagine if I have a table T, right? This is my table. My table has, let's say, name and the percentage of marks. The percentage of marks that each of the students has secured, right? So let's say I have a name N1, and let's assume the percentages are stored actually not as just a number but as a string. So they've written 59 percentage. They've actually used the percentage symbol here, let's say. Similarly, there is another N2 equals to 63 percentage. Similarly, there is a student whose name is N3. I'm just taking an example here. With let's say 96 percentage. Now comes the tricky part. Now if I want to select, okay, if I want to say select star from, right, select all the columns from my table T where let's say where percentage equals to, let's say if I say 96 percentage. When I say this, there is a problem. The problem is because percentage is a wildcard character. Let's not forget that. Is a wildcard character which represents 0 or more characters. Okay. So SQL will think of this as a wildcard. SQL does not think of it as a symbol percentage. There is a difference between wildcard character percentage and the symbol percentage. We want it to be thought of as a character or symbol percentage. That's what we want it to think of it. If you look at your keyboard, on your keyboard above the 5 numeric pad, above the 5 number you have the percentage symbol. That's what we want it to represent, not the wildcard character. In such a case, what do we do? So instead of writing it like this, because this is interpreted as a wildcard character, the default interpretation is a wildcard character. The appropriate way to write this would be where percentage, everything stays the same. Select star from T where percentage equals to 96. We can use something called as an escape character called backslash. Look at this. This is how it should look like. Right? This is exactly how it should look like. It should be backslash percentage. Now, whenever you say backslash percentage, this will be interpreted as the symbol percentage, not as the wildcard character percentage. So this backslash is often referred to as the escape character. It is called the escape character. Every language, every programming language has escape characters. This is the escape character in SQL. Right? I hope this is clear. So if you don't want a percentage, if you think a percentage is there in one of your data, in one of your columns, and if you don't want percentage to be treated as a wildcard character, but as a symbol, then you should use the escape character, which is the backslash. Actually, this, because we have two, remember, we have two wildcard characters, right? We have percentage and underscore. Underscore becomes very important. Let me tell you an example there, right? Suppose I have a table T. I'll give an example for that also. Let's assume I have the email addresses. Okay, I have person with N1 whose email address is n1_abc@gmail, let's say. Right? Let's assume this is a person's email address. Similarly, there is a user N2 whose this thing is _xyz_abc@gmail. Now here underscore, remember this is very, very important. Here we are using underscore as a symbol underscore, not as a wildcard character. So here, if you want to search for somebody based on their email address, I can say select star from my table T where email equals to, if I just say email equals to n1_abc@gmail. Let's say I said this. Let's assume I said this. Now automatically, this underscore is treated as the wildcard character. Right? Where email like, let's say I say instead of equal to, if I said like, not equal to, but I said like is the logical operator that we are using here, right? Like is the operator that we are using. Sorry, it shouldn't be equal to, it should be like, right? Like on n1 underscore ABC. Now this underscore is now being treated as a wildcard character, but we want to treat it like a symbol. In such a case, what should we do? In such a case, we should write like, right, where email like, right, n1 backslash underscore abc at gmail.com. So the moment you use this escape character, you are saying whatever comes next should not be treated as a special character, it should be treated as the symbol. Right? Very simple. So even here, we shouldn't say percentage equals to, we should say percentage like. Because this is a string matching, right? That we want to do with wildcard characters. Right? That's a small correction that I just wanted to make here. So overall, in a nutshell, overall, if you think about it, what we have here is that we can use escape characters to treat the special symbols like percentage or underscore as symbols and not as wildcard characters, right? So we have gone through almost all the major logical operators that we started off with, except any and all. So we have gone through and, or, not. These two we'll go through when we learn about subqueries little later. We went through between, exists, in, like, and some. So we'll also come across some little later actually. We haven't gone through some here, right? So very, very simple examples, nothing complex, very useful logical operators in practice.